Okay, now classroom workbook problems of wideband FM. Question number 3. A carrier wave frequency modulated. A carrier wave is frequency modulated by a sinusoidal signal of frequency 2 kHz resulting a frequency deviation of 5 kHz, Now what he is asking here is also asking 2 bits. This is frequency of the message signal is 2 kHz and the frequency deviation is 5 kHz. This is given. Then he is asking to find bandwidth. What is bandwidth? Very simple question. What is bandwidth? Beta, which is equal to delta F by Fm, which is equal to, or you can write like this directly, no? Bandwidth, which is equal to 2 into delta F plus 2 into Fm, or delta F by Fm beta also you can calculate, not an issue. Okay, so 2 into delta F is 5 kilo plus 2 into Fm is 2 kilo, which is equal to 10 plus 4. 14 kilohertz is the bandwidth. Okay, or you can write like this also. Beta equal to delta F by Fm. Delta F is 5 kilo by Fm is 2 kilo, which is equal to 2.5. Now this is bandwidth, which is equal to 2 into beta plus 1 into Fm, which is equal to 2.1 plus 1, 3.5 into 2, 7, 7 into 2, 14, same answer. Okay, audible. Now what is B bit? Now repeat the above calculation. The message signal frequency is the amplitude of the message signal. The amplitude of the message signal is increased by a factor of 3. The amplitude of the message signal is increased by a factor of 3 and the frequency is decreased to 1 kHz. And the frequency is decreased, means previously 2 kHz and it is decreased to 1 kHz, which is nothing but Fm by 2. So what about the modulation index? Now the modulation index, which is equal to Kf into Am by Fm. Which is equal to Kf into, this is 3 Am by Fm mu, which is equal to Fm by 2, which is equal to 6 into Kf into Am by Fm, which is equal to 6 into beta volt. Which means that what you can understand, when message signal amplitude is increased by a factor of 3 times, message signal frequency is decreased by a factor of 2 times, and a modulation index is increased by a factor of 6 times. Beta is 15. Now bandwidth, which is equal to 2 into beta nu plus 1 into Fm nu, which is equal to 15 plus 1, 16 into 2, 32 into 1, 32 kilohertz. Now this is question number 3. Now question number 4. A 10 MHz carrier signal, is frequency modulated by a sinusoidal signal such that the frequency deviation is 50 kHz. Calculate the bandwidth of the FM signal. If the message signal frequency is 500 kHz, and the message signal frequency is 500 Hz. Calculate the bandwidth of the message signal. Now see here. Now if you want to calculate the bandwidth, first modulation index beta. What is the modulation index beta here? The modulation index beta, which is equal to delta F by FM, which is equal to delta F is 50 kilo by FM is 500 kilo, which is equal to 0.1. Now, most of the students are doing the mistake is when beta equals 0.1, the students are immediately writing that 2 into beta plus 1 into FM is 100% wrong answer. Once when the beta value is available with you, first you have wait a second and identify that this beta 0.1 is a narrowband FM or a wideband FM. This is beta less than 1. Therefore, it is not a wideband FM, it is a narrowband FM. Then the bandwidth formula is not this. The bandwidth formula, which is nothing but 2 into FM, which is equal to 2 into FM is 500 kilohertz. Therefore, bandwidth, which is equal to 1000 kilohertz. Now, the modulation index beta here is delta F by FM. What is delta F? Which is 50 kilo by FM, which is equal to 500. Therefore, now this is nothing but 100. Now this is wideband FM because beta is greater than 1. So now the bandwidth, which is equal to 2 into, now this formula you can utilize, 2 into beta plus 1 into FM. Before you apply any formula, first you identify beta is a narrowband FM, wideband FM. Narrowband FM, one formulas, wideband FM, another formulas. An FM signal represented in time domain as S of t, which is equal to 20 into cos 2 pi into 10 power 6 into t plus 10 sin 2 pi into 10 power 3 into t. An FM signal represented in time domain as 20 cos 2 pi into 10 power 6 into t plus 10 sin 2 pi into 10 power 3 into t is radiated into free space with an antenna resistance of 50 ohms. Now what he is asking is, now first you compare. Now what is the standard FM signal? An FM signal which is equal to AC cos 2 pi FCT plus beta into sine 2 pi Fm into T. Now while comparing these two, AC which is equal to 20 volts, FC which is equal to 1 megahertz, modulation index beta which is equal to 10 when beta greater than 1, and frequency of the message signal which is equal to 1 kilohertz. This is wideband FM. This is wideband FM. Now the modulation index beta which is 10 which is greater than 1, this is wideband FM. Now see here what he is asking. Now the A bit is determine, calculate the total power. What is the total power? The total power which is equal to an unmodulated carrier power AC square by 2R which is equal to 20 into 20 by 2 into R equal to 50 ohm. Four watts. Now B bit, he is asking, the B bit is calculate the total power, calculate the power taken by the carrier component. What is the power taken by the carrier component? AC square J naught square of beta, because each spectral component amplitude depends upon the Bessel function quotient. AC square by 2R is already calculated into J naught square of beta. What is beta? Beta equal to 10. But in the question is already mentioned 4 into J naught of 10 which is given as 0.25. This is 0.25 whole square, because in the question is mentioned J naught of 10 which is equal to 0.25. Okay. Now this is asking the total power, and is also asking the power taken by the carrier component, question number 5, which is very important based on complete concept wise. What is the concept I just explained here? Okay. This is an AM transmitter. AM transmitter transmits AM wave. And this is an FM transmitter. FM transmitter transmits FM wave. He says that both of the transmitters uses same carrier. Both of the transmitters uses same carrier. Both of the transmitters uses same carrier and same message signal frequency FM, which is equal to 4 kilohertz. Here is also the same message signal frequency FM, which is equal to 4 kilohertz. And he is giving one statement that the bandwidth of FM is 4 times the bandwidth of AM. The bandwidth of FM is 4 times the bandwidth of AM. So which here I can get a bandwidth of FM which is equal to, frequency deviation. A frequency deviation of FM is 4 times the bandwidth of AM. So the frequency deviation of FM which is equal to 4 times the bandwidth of AM is 2 FM. So delta F which is equal to 8 FM. So the modulation index beta which is equal to delta F by FM which is equal to 8, which is greater than 1, wideband FM. Now this is the modulation index beta which is greater than 1, which is wideband FM, and he is asking one question: what is the modulation index in FM? Answer is completed, right? And another question is asking the spectral amplitude of FC plus 4 kilohertz. Now this is FC. What is FC plus 4 kilohertz? This is FC plus FM, which is means that FC plus 4 kilohertz. The spectral amplitude of FC plus FM, FC plus 4 kilohertz, which is nothing but AC J1 of beta by 2. Now what is the spectral component of Fc plus 4 kHz here? Here it is Fc, this is Fc, and this is Fc plus Fm. Fc plus Fm, which is nothing but Fc plus 4 kHz. Now the spectral amplitude of Fc plus Fm, which is AC mu by 4. And in the question he is mentioned that the spectral amplitude of Fc plus 4 kHz in AM and in FM both are same. These two are same. If these two are same, can I equate these two? Yes. AC mu by 4, which is equal to AC J1 of beta by 2. AC cancel, 4 cancel. Now the modulation index mu, which is equal to 2 into J1 of beta. So the modulation index mu, which is equal to 2 into J1 of beta. What is beta? Now the modulation index beta is 8, J1 of 8. And in the question is mentioned 2 into, what is J1 of 8? J1 of 8 is already given in our question paper. J1 of 8 is 8. J1 of 8 is already given in our question paper. J1 of 8 is 0.235. 0.235. Therefore mu, which is equal to 0.47. This is the what is modulation index in AM and what is the modulation index in FM. He is asking these two questions, then these two are over. 7. In our workbook, question number 7. An AM transmitter radiates, see here, an AM transmitter radiates 100 watts. An AM transmitter radiates 100 watts when no modulation is present. The AM transmitter radiates 100 watts when there is no modulation. Means what? There is no modulation. No modulation means this power is nothing but unmodulated carrier power. Am I not? An AM transmitter radiates 100 watts when there is no modulation, which means unmodulated carrier power. Now the carrier is frequency modulated. Now the carrier is frequency modulation. Now the frequency modulation is done by adjusting modulation index. Now the frequency modulated by a sinusoidal signal and the modulation index is adjusted. The modulation index is adjusted such that what he is saying is the modulation index is adjusted such that first order sideband. Modulation index is adjusted such that the amplitude of the first order sideband is the amplitude of the first order sideband. The amplitude of the first order sideband is 0. Amplitude of first order sideband. What is the first order sideband? What is the first order sideband amplitude? AC J1 of beta. Okay, first order. This is n equal to 1. First order sideband amplitude is AC J1 of beta. If it is the spectral amplitude, AC J1 of beta by 2. But this is a amplitude. That is, spectral amplitude is not mentioning amplitude. Now first order sideband amplitude is AC J1 of beta is equal to 0. Now what happens? J1 of beta, which is equal to 0. But in our options, in our question there he is giving some values. J1 of 3.8 is equal to 0. While comparing these two, we can identify that beta equal to 3.8, beta which is greater than 1, which is nothing but wideband FM. So now what he is asking, this is the given information. Okay, all these things are given information. But what he is asking, under this condition, he is asking a bit power taken by the carrier component, the power at the carrier frequency. Power at the carrier frequency, which is nothing but AC square by 2R into J naught square of beta. This is the power taken by the carrier component, AC square by 2R into J naught square of beta, the power at the carrier frequency. Now you see here, AC square by 2R into J naught square of beta is 3.8. What is AC square by 2R? Now in the question is mentioned any AC value, amplitude of the carrier is given. No, amplitude of the carrier is not given, but what is given is when no modulation, this is PC. But this is wideband FM. Whenever in wideband FM we have another value here. In wideband FM, the total power which is equal to unmodulated carrier power which is equal to AC square by 2R, which is already given, which is nothing but 100 watts. Okay, whatever the unmodulated carrier power will be the total power in wideband FM. You can utilize that, which is equal to 100 into J naught of 3.8 is given as J naught of 3.8, 0.4 is given 0.4 whole square. All these things are information is given, which is nothing but 16 watts is the power taken by the carrier component. And what he is asking, then the B bit is power in all the remaining side bands. Now what is the total power? The total power is nothing but power taken by the carrier component and power in all the remaining side bands. Now what he is asking is power in all the remaining side bands, which is equal to total power minus power taken by the carrier component. Now the total power which is equal to 100 watts, power taken by the carrier is 16. Therefore this is nothing but power in all remaining side bands are 84 watts. And CBT is also asking power in the second order side band. Now power in the second order side band. The power in the second order side band is AC square by R into second order J2 square of beta, which is equal to AC square by 2R is available here. From here AC square by R, we want AC square by R, which is equal to 2 into 100, therefore which is nothing but 200. Now AC square by R, which is equal to 200 into J2 of 3.8 whole square. This is also given 200 into J2 of 3.8 is 0.41 whole square, which is equal to 33.62 watts. This is the power in all the remaining side bands, power at the carrier frequency, power in the second order side band. An FM wave is generated with the help of message signal and a carrier signal, and a message signal amplitude and a message signal frequency of 2 kHz. What is given? A carrier is frequency modulated by a sinusoidal signal of amplitude AM of frequency FM. A certain experiment is conducted with FM equal to 1 kHz and increasing the AM value. AM value is increasing from 0 volts. This is 0 volts and so on and so on. When AM is increasing, and it was found that when AM equal to 2 volts, it found that the carrier component is reduced to 0. Carrier component is reduced. The carrier component is reduced to 0 for the first time. The carrier component is reduced to 0 for the first time. Now, when the carrier component will become 0, the carrier component will become 0 when J naught of beta will become 0, carrier power will become 0. The carrier component will reduces to 0 for the first time which means that beta, which is equal to 2.4. He is giving one information, reduces to 0 for the beta equal to 2.4, beta equal to 2.4, 5.5, 8.6, 11.8. For those values of beta, J naught of beta, which is equal to 0, when J naught of beta equal to 0, the power taken by the carrier will become 0. So this is the first time, therefore this is the first time beta equal to 2.4 is information. Now under this condition, he is asking to sensitivity of the frequency modulator. Now tell me under this condition what is beta? Beta, which is equal to kf into AM by FM. He is asking the sensitivity of the frequency modulator kf, which is equal to beta into FM by AM. Beta is given 2.4, FM is given experiment at 2 kilohertz, and amplitude of the message signal is 2 volts. Therefore, 1.2 kilohertz per volt is the sensitivity of the frequency modulator. Now again AM is increasing, but this time we missed to see the AM value, but now carrier component, carrier amplitude or a carrier component is reduced. The carrier component is reduced to 0 for the second time. The carrier component is reduced to 0 for the second time. The carrier component is reduces to 0 for the second time when beta equal to 5.5. Now the carrier component is reduces to 0 for the second time, which means that beta, which is equal to 5.5. Now, what is the amplitude of the message signal under this condition? AM, which is equal to beta into FM by KF. Now, beta, what is beta? Beta is nothing but 5.5 FM, which is equal to 2 kilohertz by KF, which is equal to, just now we are calculating 1.2 kilohertz per volt, which is equal to 4.58 volts. Sorry, this FM is 1 kilohertz. FM experiment is conducted at 1 kilohertz. Therefore, this is 1 kilohertz. Then only this is 1.2. Therefore, this is 1 kilohertz. Then this 555 by 1. This is correct. FM modulators. There are two ways to generate an FM wave. One is direct method and second one is indirect method. Okay, one is direct method and the second one is indirect method. Now, what is the direct method? What is the FM? FM is nothing but voltage is converted to frequencies. Am I not? The voltage variations are converted to frequency variations. FM modulator is nothing but voltage to frequency converter. I am already saying, okay, voltage to frequency converter. Okay, therefore now you see here voltage controlled oscillator, because now this is voltage variations I am giving and I want the oscillations I required. Okay, that's why this is called as voltage controlled oscillator. As the controlling voltage is a message signal, based on this message signal voltages, and these frequencies are varied, and morning also I am explaining. Okay, so voltage to frequency variation. So how it will be generated, we will see in the direct method. So the direct method is to generate a FM wave when the controlling voltage is message signal with the help of VCO, voltage controlled oscillator. Okay, what is voltage control oscillator? I will show you. See here. Now this is a simple oscillator circuit, a Hartley oscillator I am giving, means LC tuned circuit. Now this is LC tuned circuit. This is L1, L2. This is C0, fixed capacitance, fixed one. Because of this fixed capacitance, what is the fixed frequency? What is the frequency generated by this oscillator? F0, which is equal to 1 divided by F0, which is equal to 1 divided by 2 pi into square root of L1 plus L2 into C0. Therefore, F0, which is equal to 1 divided by 2 pi root L equivalent into C0. This is the fixed frequency. This is the fixed frequency because of fixed capacitance. Because of fixed capacitance. Okay, this is the fixed frequency and because of the fixed capacitance. Now this oscillator is a slight change here. This oscillator L1, L2, C0 and a Hartley oscillator with a varactor diode. Okay, now a controlling voltage is M of T. Okay, now even there is no controlling voltage here, under open circuit also it will generate one frequency which is F0. Okay, there is no controlling voltage here, but there is a controlling voltage of M of T here. Then what is the frequency produced by this VCO is Fi, instantaneous. Can I write like this? 1 divided by 2 pi root L1 plus L2 L equivalent into C0 plus C. Let us assume some C dash, C0 plus C dash, C0 plus C dash. Now Fi, which is equal to 1 by 2 pi root L equivalent into, this is the variable capacitance now. Okay, this is fixed capacitance. Now when this C dash, when the controlling voltage is available, now this is the variable capacitance now. These together, now this will become variable capacitance. So can I write like this? This variable capacitance as C of T. Now this C0 plus C dash, which is equal to C of T, can I represent it like this? C0 minus Kc into M of T. When M of T equal to 0, this fixed capacitance is nothing but C0. When M of T is present, this capacitance is varied. This is a capacitance. This is capacitance value, capacitor. Not carrier, capacitance. Okay, so if I replace with that Fi, what is Fi here? Fi, which is equal to 1 divided by 2 pi root L equivalent into C of t is C naught minus Kc into m of t. Because when controlling voltage is available, this capacitance value is changes. When this capacitance value is changes, then this frequency is also changes. Okay. So therefore, Fi, which is equal to 1 divided by 2 pi root L equivalent into C naught if you take it as a common, C naught if you take it as a common, which means that 1 minus Kc by C naught into m of t. Now Fi, which is equal to 1 divided by 2 pi into root L equivalent into C naught. Now if you take this root 1 minus Kc by C naught into m of t. Fi, which is equal to 1 by 2 pi root L equivalent C naught, which is nothing but F naught into, this is a fixed capacitance, 1 minus Kc by C naught into m of t whole power minus 1 by 2. Now this is, see here, this is a smaller value, this is a small value, 1 plus x whole power n is approximately 1 plus nx, where x is a small value compared with 1. Now similarly, if you substitute this, Fi, which is equal to F naught into 1 minus, this is minus minus plus 1 by 2 into Kc by C naught into m of t. Therefore, Fi, which is equal to F naught plus F naught into Kc by 2 into C naught into m of t. Fi, which is equal to F naught plus, this is the sensitivity of VCO, kV into m of t. Now see here, this is Fi, which is equal to F naught plus kV into m of t. What is kV? kV is the sensitivity of voltage controlled oscillator. Understand or not? Now see what happened now. When message signal, when the controlling voltage is 0, see here, you can easily understand. When the controlling voltage, when m of t equal to 0, therefore Fi, which is equal to F naught plus 0, when the controlling voltage is 0. But when m of t is maximum, Fi is maximum, because Fi, which is equal to F naught plus kV into m of t maximum, therefore you may get Fi value as maximum. And when m of t is minimum, when m of t value equal to minimum, so this is nothing but Fi, which is equal to F naught plus kV into m of t value minimum. Therefore, which results now Fi is minimum. Then what we can understand? Now the frequencies of the voltage control oscillator is changed continuously according to the controlling voltage, which is nothing but the message signal strength. When this message signal strength is changing, then this VCO will generate a different frequencies. Even when the message signal voltage is 0, VCO is generating some frequency, because when m of t is 0, this varactor diode will not work, but because of this fixed capacitance, it will generate one fixed frequency. Okay. Now this is a varactor diode, variable capacitance. When this varactor diode comes into picture, then this capacitance will become variable. Okay. So when then there is no varactor diode, then varactor diode is not present, then then this controlling voltage is 0, varactor diode is in inactive state. Now because of this fixed capacitance C0, one fixed frequency F0. But when this controlling voltage is present, then this varactor diode is present, then variable capacitance will give the different frequency. Okay, so this is the controlling voltages, and this is the VCO will generate a different frequencies. Okay, now this is the voltage variation is converted to frequency variations, and this is the sensitivity of the voltage control oscillator. Same hertz per volt cancel hertz. Okay, so this is a derivation part, but this derivation part is not required, but you can understand what is this is VCO, because the same thing we can used in a digital modulation technique also. What is VCO? Directly I am writing there, I am not mentioning everything. This is voltage control oscillator. Now this is the instantaneous frequency when the input is controlling voltage, which is nothing but message signal simply. Okay, no doubt. Okay, I just observed here, this is a fixed capacitance. Because of this fixed capacitance, fixed frequency. When under open circuit, no voltage, no controlling, nothing here. But now in the same thing, now I just connected to a varactor diode, variable capacitance. Now with a controlling voltages of M of t. This varactor diode is active position when the controlling voltage is existing. Okay. Now this is C of t. Now why I am writing like this? This is farads, units are, this is C0, fixed capacitance, units are farads. Okay, but this is volts, controlling voltage. Now this is the sensitivity of the capacitor. Now this is nothing but farad per volt. What is Kc? Kc is the sensitivity of capacitor. So why I am writing like this? Generally, when M of t equal to 0, what is the capacitance? When M of t equal to 0, the overall capacitance is only C0. But when M of t is positive, now the C0 minus something, but M of t is negative voltage. So minus plus, more capacitance. Reverse bias means conduction is 0. Now depletion width is more capacitance. Okay, that's why I am writing this minus sign for positive and negative differentiation. Okay, so this is when M of t is existing, capacitance is changing, frequencies are generating. When M of t is 0, now fixed capacitance, fixed frequency. Okay, now this is the direct method, and next class we will see the indirect method.